Hi, Ivan here from Clubscraft, where we help sports coaches spend more time with their athletes. And today we are going to talk about training intensity and how we are going to measure it, because we want to tax different mechanisms in our body to get the best possible performance enhancements. And that's why we are going to look into different ways on how we can measure this intensity and then look at some of the benefits and drawbacks each of those has. The first way of measuring intensity is pace. Pace by itself isn't really that applicable to, for example, cyclists because of the vast distances they cover and the terrain they are encountering. But for example, for runners or swimmers, this is a great way to know if they are going too slow or too fast. Pace wasn't really a reliable way of training before we got some assistance by technology, because if you are running in a loop of a known length, you would have to check the time you needed to complete the loop, then do some calculations in your head. And you could only do this once per lap. So if you're going too slow or too fast, you would have to wait an entire loop before you got the feedback. But now that we have GPS watches, we can get instant feedback on our pace and then adjust it as we need. One more level of precision that we can add to pace is if we use some kind of accelerometers like pods which we can attach to our running shoes, for example, and then coupled with our sports watches, we can get a precise estimate of pace. One of the negative sides for using pace as a measure of intensity is that a lot of athletes need to look at the watch quite a lot of time, so they really don't develop the ability to feel the intensity or feel the stress and exertion they have to put into or to hold a given pace. So they are really relying too much on technology instead of listening to their body. Another way of measuring intensity is by using the rate of perceived exertion, or basically how you feel. So there are many different ways we can split this up. One is a simple 1 to 10 scale, where 1 means no exertion at all and 10 means I'm doing all out and I can hold this just for a few more seconds. The Borg scale of perceived exertion, which goes from 6 to 20, which looks a little bit weird, but the 6 represents an average person who has 60 beats per minute when they're doing nothing basically, and 20 means just 200 beats per minute. So it's just a simple multiplication exercise. So if you are at the low spectrum, your heart rate will be low and you will be closer to a 6, where if you're going all out, you'll be closer to 200 or a 20 on that scale. It's somewhat of an imperfect scale because different people have different heart rates based on their perceived exertion, but it's again something that can help you quite a lot in gauging your relative effort for a given day. Ever since the 1980s, when we had wireless measurements of heart rate, we as athletes started looking into how we can use this to our advantage. But unfortunately, heart rate by itself is somewhat of an opaque window into our body's state, because heart rate takes sometimes a lot of time to catch up to the intensity we are working on. And then once we stop, the heart rate will still be relatively high until a certain point where it starts to slow down, when our body realizes that we are now not in need of so much energy anymore. The heart rate or which heart rate we are going to base off our trainings is also a little bit difficult. Some advocate for using the maximum heart rate. So you would go and do a field test and then try and get your heart rate as high as you can. But this requires a lot of motivation, because at one point you will fall into a very unpleasant state where everything is going to hurt. And your goal is just to keep pushing until you really cannot do any more. This approach unfortunately has the drawback that some people will have their lactate or anaerobic threshold at, let's say, 85, 87, 90% of their maximum heart rate, while other people's lactate threshold is going to be closer to 90, 92, 95. So if you prescribe the same workout to two different athletes, one might be below their anaerobic threshold, the other one is going to be slightly above, and then they will be doing basically the same training session, but they will be taxing different mechanisms in their body, negating what you want to achieve. So that's why it's much better to use the heart rate at the lactate threshold, because this is going to be basically different for everyone, and then basing all the training intensity levels of this heart rate at lactate threshold is going to give you much more power about fine-tuning the training sessions for your athlete. One other thing that you can do here is combine, for example, heart rate and rate of perceived exertion, because if you just rely on one data point, it's going to be very tricky to always have the right information. But the more data points you add, it's going to be a lot easier for you to determine the actual intensity at which you're working on. One of the most objective ways of measuring intensity is by using a power meter. This is especially popular among cyclists because there are different ways of measuring the power they are putting out, and it is completely separated from any environmental issues, because it doesn't matter if you're going with the wind, against the wind, up a hill, down a hill, your power output is always going to be how much you are putting effort into cranking those pedals. So if you are, for example, a little tired this day, your heart rate might be a lot higher than it normally is, but your power output is always going to be a reflection of how much effort you're putting into it. And this is why a lot of coaches and athletes use power meters. They aren't cheap, but there are now a lot of options on the market, so the prices are going down with time. And if you have to decide if you're going to buy, for example, a new set of wheels or a power meter, you should always opt for a power meter first, because it's going to give you instant feedback on how you're performing. And even during races, you can have a detailed power plan, and then you just have to look at your power meter by computer, and it's going to tell you how much you're generating power, and you just have to follow the numbers and not think about too much about where the wind is blowing and if you're going up a hill or just cruising down. And again, if you combine this with the rate of perceived exertion, or if you're using, for example, a heart rate monitor as well, this can give you a really good insight into your current abilities and if you can push a little more than usual. One of the ways you can also measure training intensities is by measuring the blood lactate of your athlete during training. But this is still something that's reserved for elite athletes and is mostly confined to some labs. But there are now some products available on the market where you can do those things by yourself. But unfortunately, it takes a little practice, because you can contaminate the blood samples you take from your finger or earlobe and contaminate it with, for example, some dirt or sweat or something like that. And this can then have effect on the analysis. And the analysis itself isn't real time, unfortunately. And you can only after the training, you can see how your athlete performed during some given intervals. So no matter what you use to measure intensity, just make sure not to use just a single data point. The more data points you add, the better it is for you, and the better you will be able to tailor those workouts to your athlete's needs and goals. You can also read a full breakdown of this topic on the blog post. You can find the link in the description below. And tomorrow we are going to look into how much time you should spend in different training intensity zones, depending on what you want to achieve. Until then, bye-bye.